Hello guys, welcome back to Tom's SAT class. I'm Tom, and today we're going to go over the concept of linear equations. Um, we're going to go through part one of linear concepts today. First, we're going to talk about terminology, and then we're going to hit some equations and graphs, and then we'll talk about the relationships that slopes have and constants have, and how they affect your equation and your graph, and how to use these knowledges to our advantage when going through the SAT problems. And then today we're gonna try all five problems at once after we go through the three concepts that we're gonna learn first. And actually, I think it's four problems today. Okay, so most of you coming into this, I assume you have a very basic understanding of linear equations already. We'll review some simple stuff, and then I'll try to jump into some tips and tricks you can use to use that knowledge and exploit it to its fullest. So first, let's learn some terminology. So the most standard equation that you guys probably remember about linear equations is the equation y equals mx plus b. This is the equation that's most popular to be used in math when you talk linear equations because it's the easiest to read through. It's the prettiest to look at. And I have y equals mx plus b. For those of you that know, that's done this for a little bit and have taken algebra 1 or even pre-algebra, you know that in a linear equation, y and x are meant to be the variables, so they're the parts of the formulas that remain as letters because you plug one number in to find the other number. But the m and the b value are terms that you're supposed to be able to find values for. So a very standard looking linear equation is something like y equals 3x plus b, or three. A very standard equation that you guys can see is something like y equals 3x plus 7. Okay. So in this case, the m is supposed to be a slope, which is supposed to be a number, so that becomes 3. The b is supposed to represent y-intercept, so it is also supposed to be a number, so I just randomly picked 7 so that we can analyze each term here. If you're not sure what slopes and y-intercepts are, I'll explain that to you in the next slide. For now, I just want to be able to look at an equation so we can describe everything here. 3 words that you should understand in terms of equations and expressions are the words coefficient, constant, and variables. And they describe every part of every expression and equation you'll ever see. First, let's start with the concept of variables. And variables are essentially their letter representations of numbers. That are subject to change. So in this equation, my variables would be the y and the x, because if I plug in a different number in for x, I'll get a different value for y, and the same is true vice versa. Constants are the numbers that are simply just the numbers themselves. They're not multiplying by any variables, they're not attached to any variables, they're simply just numbers that are always going to stay exactly the same. So in this scenario right here, my 7 would be the constant there. The term for coefficient is the constant that is multiplying by a variable. So then that in this equation right here, 3 is the term that's multiplying by a variable. So then that's the one that would be the coefficient. And before we move on into the next section, I just really wanted to quickly talk to you about the concept of slopes and how they function. So I have y equals 3x plus 7 right now. And if I were to plug in a value for x, and I do this in the form of a coordinate where the first number is always supposed to be x, second number is always supposed to be y, and I stick a 1 in for the x value, that means a 1 goes in here, so then I have 3 times 1 plus 7, which is equal to 10. So now I have a different result for the y value, which is going to be 10. So one point that I would be able to graph with this equation is a point 110. And if I plug in 2, 3 times 2 is 6, plus 7 is 13. So then another point I have is 213. And every linear line, anytime you have an equation with two variables, you can do this an endless number of times where you pick one number for the x value, and then by plugging the number into the x value, you can crank out the rest of the formula and figure out what your y value is supposed to be. And not only that, and we'll discuss this more in depth in like a little bit, but for right now, something you should recognize about the coefficient for linear equations is another word for it is slope. And the slope describes the change in behavior of how much the y goes up by when the x value goes up by 1. So every time the x value goes up by 1, the y increases by whatever the slope is. So in this case, the slope should be 3. And let's see how that works when we try to plug in points. So my first point I had was 110. And when the x value went up by 1, the y value went up by 3. And if I use this, and if I use the same equation and find that when I plug in the x value of 3, I get 16, you'll notice that the slope here is having a dominant effect where every time the x value goes up by 1, the slope goes up by 3. And having that understanding is super important because slopes is a very common used thing in algebra and in the SATs. And I'll show you what that 7 does in a second. So this is the terminology. You want to make sure you know what they are and how to use them when you take the SATs. So now let's talk about some graphs and how equations relate to graph and how graphs relate to equations, as well as the 3 options that we actually have for graphs. The 3 formulas we have to represent equations. So there are 3 main forms of linear equations to keep track of. You will see the slope-intercept form more than anything else, but as a rule of thumb, you should remember all 3. So the 3 types of linear equation you'll see are slope-intercept, which comes in the form of y equals mx plus b, where the m and the b are numbers I need to find in order to do the problem, in order to have an equation where I can find points. Another formula that exists is called the point slope form. And in that one, the formula is y minus y1 is equal to m times x minus x1. And I know this one looks a little bit grosser than the slope-intercept form, but it also has its uses. And in this case, the 3 numbers you will need to find in order to make this a full linear equation is you need to find the slope, and you need to find x1, and you need to find y1. And then lastly, we have the concept of standard form, which comes in the form of ax plus by is equal to c. And once again, the x and the y values are the values that would stay as the variables, and our job is to find a, b, and c, and be able to manipulate it the way we feel like we need to for the formatives and summatives that we take and work on. Okay, so first let's talk about slope-intercept. That's the easiest and the most popular. So we'll get that out of the way first. So with a slope-intercept form, the m is what is known as the slope, and the b value is what is known as the y-intercept. Now, I already told you what slope means in the last section, but we'll talk about it again. The slope is the change in y value when x goes up by 1. And we can use our understanding of the slope to graph new points. And the y-intercept is a number that guarantees your first point in your graph, so that you know your first point is always going to be 0, b, as in whatever the b value is, that is the y value for, that gives you a point for what the y value is when the x is equal to 0. And we're going to put this practice by writing our own equation and coming up with a way to graph it. And let's make this a minus here. Let's do a -3. So if I have something like y equals 5x minus 3, first thing I'm going to do is get the point that I'm supposed to be able to start with. In this case, I can see that the -3 matches with a y-intercept. So my first point is 0, -3. And now that I've got my first point, I just need to be able to describe the change in slope. So my slope is a 5, which means when, and I'm following this rule over here, okay? So when I graph, when x goes up by 1, y goes up by the slope, which in this case would be 5. So then I would start at 0, -3, move 1 unit to the right, up by 1, 2, 3, 4, 5 units, and now I have 2 points. And anytime you have 2 points and you know you got yourself a linear line, that's how you know you are done. And then you can draw a straight line through them, either with your straight edge or just by sketching it. When you're taking the SATs, they will not actually provide you with a graph. So getting comfortable winging it is a very good tool too. And one thing you should know is that when you are dealing with the understanding of equations and graphs, you need to be able to take an equation and turn it into a graph. But likewise, you also need to be able to look at a graph and be able to turn it into an equation. And being very, very comfortable doing both tasks for each one of these formulas is a really good tool for you to have. So that's what slope-intercept offers, slope and the y-intercept. So now let's talk about the point-slope form. So the point-slope form is a slightly different looking formula, but it provides us the same service of being able to graph it. So this is y minus y1 times m times x minus x1. So once again, when we do linear equations, we recycle variables and numbers and formulas. So this m here is still the slope. And once again, we are given our first point. they actually give it to us in this case, because x1 and y1 are supposed to be constants that they find, and it is going to provide us with our first point in the equation. So an example, and we'll try to graph that example based on this situation right here. So if I have y minus 3 is equal to 2 times x minus 4, then I can tell relatively easily that the slope in this case is supposed to be a 2. And my first point, if I decide to match the -3, the -3 over here and the 4 over here with this formula, you'll notice that the formula already says y is minusing by y1. So in this case, y1 is simply just the 3 itself, and x1 is simply just the 4, meaning my first point given to me is 4, 3. So I have 1, 2, 3, 4, 1, 2, 3 as my first point, and then my slope is 2, so I'm going to go right 1, up 2 in order to get to this point right over here. And from here on out, I can use a straight edge, and you guys can too, to graph graph out what the rest of the line is supposed to look like. And I'm going to leave that right there. That's long enough. And now we have the ability to graph this line based on a point slope form. Just keep in mind that once again, you're expected to be able to do this process both ways, going from the equation to the graph, and then from the graph to the equation. And I'm going to show you right now the standard form next. So standard form looks a little bit different than point slope and slope intercept. Standard form looks like this: ax plus by equals c. So once again, the x and the y values here are the variables. So then in order to write out a full standard form linear equation, the very letters that we need to turn into numbers are a, b, and c, where the a and b are coefficients, and the c would be the constant. And you'll notice that this one feels a little bit tougher because we're not really given a slope, so it might feel a little bit weirder to graph this. And I will tell you that anytime you have a standard form equation, you know it's a linear equation because the x and y are both to the first power, and neither one of them are in the denominator. So the slope-intercept form gives you a slope and your first point. Point slope form gives you your slope and your first point. What the standard form tells you is actually 2 points, and I'll show you how to work that math in a second. So I'm going to make one up. Supposing we have 2x plus 4y is equal to 8. So this feels like a pretty standard form linear equation. Now I know the attempt that most of you guys will go through is you're going to try to isolate the y by minusing 2x on both sides, and then dividing by 4. So you get y is equal to 2 minus 1/2 x, and then you go to graph that situation. But we're not really trying to do all that. We're trying to get through this as quick as possible, and rather than turning it into a different form and then graphing that based on that form, um, I'm going to show you a different way to do it. And I believe it was 2x plus 4y is equal to 8. Like I said before, standard form gives you 2 points, and the 2 points they're giving you are the intercepts. They give you the x-intercept and the y-intercept. And you already know this. The y-intercept is when the x value is going to be 0 because it's happening on the y-axis. And then this number here would be the y-intercept. And then likewise, the x-intercept is when your line intersects with the x-axis, which means the y value is supposed to be 0, and our job is to find x. And what you can do is plug this situation into the equation in order to find out what the y value is supposed to be. So if I decide to try to find the y-intercept right now, that's me plugging in 0 for x, so I get 2 times 0 plus 4y is equal to 8, which is really just 4y equals 8, because 2 times 0 cancel. So then y is equal to 2. So then my first point is 0, 2. And then when I do the y-intercept, it is literally this. When I do the x-intercept, it is literally the same move. I plug that 0 in for y, so I get 2x plus 4 times 0, which is equal to 8. This cancels, so x equals 4. And now that I have 2 points, I can graph both of them. And now you have the knowledge that you can graph these 2 points relatively quickly. And standard form is one of those forms where it makes more sense for you to be comfortable knowing how to go from equation to graph. If you want to go from graph to equation, I would say the easiest way to go about it is to turn this into either point slope form, or better yet, the slope intercept form. And guys, I took all that time to do this whole explanation because I wanted you guys to understand that when you have these 3 different forms of linear equations, you're always being given enough information to graph the whole thing. You just have to make sure you know what you're supposed to know. In which case, slope-intercept form always gives you the slope, and the y-intercept form. And the point slope form gives you the slope as well as a single point on the graph. And the standard form gives you the x-intercept, which is some value that you don't know, and the y value is 0. And then the y-intercept, which is the x value is 0, and you use it to find the y value. So depending on what they give you for the equation, you can do different cool stuff with it. And with those 2 concepts completed, let's talk about slopes before we really start trying to do today's problems. Next thing I wanted to talk to you guys about is the concept of slopes and constants. Let's take a standard equation and talk about what things we need to be aware of here. So constant's easy. Constant, that is that number that never changes. And when you work off an equation, it's relatively simple to figure out whatever this part is, add by the 5 in order to get to your y value. And anytime you have a slope-intercept form, you take that 5 as the y-intercept, and it's easy peasy from there. The slope is really the thing that's a lot more interesting to think about. The slope, once again, is how much the how much the y value goes up by when the x value goes up by 1. So if I were to graph this slope right now based on my point of 0, 5, when x goes up by 1, I would go up by 3/4. So you guys might be looking at that point right now and you might be going like, well, I don't know if that's exactly 3/4. And I feel like if I have to keep doing 3/4 of a grid as you keep graphing through this, it's going to be a bit of a pain in the butt. And you are correct. It is a pain in the butt. Whole number slopes are easy to graph. And if it's positive, it goes up. If it's negative, it goes down. But fractional slopes are a little bit harder to graph because it's hard to graph a decimal of a point. So what you get to do in a situation like this is you get to understand the concept of slope as a function of the change in y value over the change in x value. And the way I graph my next point is I literally go, okay, so the 3 on top is supposed to be the change in y. By the way, in math speak, this little triangle symbol here means change. You see it in physics, it also works in math and makes your life a little easier. So we're going to go up by, up by 3. That's what the y value changes, and then over to the right by 4 because that's what the x value changes. So we go 1, 2, 3, 4. And now that I have this point up here, and I have it put onto a specific point, it's a whole lot easier to make sure that my estimation isn't off. And I can graph a linear line based on this situation. And that is the very simplest form of how to graph. And concerning graphs, there's 2 more things I want to show you. So once again, just like you want to be able to go from slope to graphing that slope, you want to be able to go from the graph of a slope to understanding what that slope is going to be. And if all you're trying to do is analyze the change in y values when the x value goes up by 1, that might not be the most enjoyable experience given that you can't really tell entire points. So I know the way they teach you in school is they teach you this formula of y2 minus y1 over x2 minus x1. And let's say I use the 2 points I started with here, which is 0, 5 and 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7, 8. So this part's 4, 8. So then what you're used to doing is picking an x1, y1, and x2, y2, and then putting it through the formula. So I get 8 minus 5 over 4 minus 0, which turns into 3 over 4, which we know is legit, so that's nice. But I don't know if you guys noticed, as I found that slope, I wrote out like 8 numbers. It was a lot to write, and it was a lot to count. It was a lot of and I had to do 2 calculations. So instead of using the slope formula like this, where you do y2 minus y1, the way I like to use it is I like to describe it as delta y over delta x. Once again, the delta with the triangle means the change, so I'm describing as change in y over change in x. And I am not even going to focus on what the particular coordinates and these numbers are. I am going to focus on the change in y value over the change in x. So the 2 points that I had in my graph fully are these 2 points right over here. And if I think about how to get from this point to this point, I am moving right by 4 and then up by 3. And now, if I describe my delta y as a positive 3, delta x as a positive 4, I now got to that slope doing way less writing, way less adding and subtracting, way less substituting. All I'm doing is just counting change in order to do that. And one interesting thing about slopes is that if you have a linear line, which means that the slope throughout the entire line is 3/4, you should be able to take any 2 points and be able to make the exact same ratio between the y value and the x value. So let me give you an example. We picked these 2 points before, and if I decide to do y over x, it would give me 3/4. So now I'm going to pick 2 other points. Let's go with this point over here, and then I'm going to go with this point over here, which is also exactly on like the intersection of these lines, so I know it's a full point. So instead of counting out the coordinates and then putting it through the slope formula, which is not the way I want to do it, I'm just going to count the change in x and y. So the x value changes by 1, 2, 3, 4, 5, 6, 7, 8. And the y value changes by 1, 2, 3, 4, 5, 6. So in the way I just did it, the delta y over delta x is not 3/4, but 6/8. But if you decide to simplify this right now, it also simplifies into 3/4. So it's a good thing to remember that when you have a linear line, you should be able to take any 2 points and be able to find the slope by understanding the change of y over the change of x. Anytime you have a linear equation, that's a move you can do. Okay, last thing I wanted to talk about in terms of slopes is the concept of a perpendicular slope. So there is a type of slope that makes there is the kind of slope that can be called a perpendicular slope, where if the 2 lines were to intersect, it would make a right angle. It would make a 90-degree angle, and when 2 lines form that relationship, you would describe that relationship as perpendicular. Now, it's not super pleasant to explain, but the rule for perpendicular slope in order to form a 90-degree angle is one rule and one rule only. In order to get a perpendicular slope, you're always going to need your original slope, because after all, we're trying to find a slope that's perpendicular to this. And perpendicular slope is only affected by the slope of your original line. It doesn't matter what the constant is at the end. It doesn't matter what point you start at. If I have a line over here, or if I have a line over here, they can both be perpendicular. So the key part is finding out what the slope is supposed to be. And to find perpendicular slope, there's one key concept, which breaks down to two key words, which is the concept of opposite reciprocal. By opposite, they mean different signs, and by reciprocal, they mean the flipped version of a fraction. So if I were to have a positive 3/4 as my original slope, my perpendicular slope would then become a negative 4/3. And that's how you use the words opposite reciprocal to get a perpendicular slope. And we can actually try this example out right now. Let me pick a point and then have it go down by 1, 2, 3, 4, 1, 2, 3. So that's going to be this point right over here, a straight line through that point. You'll notice that it looks like it forms a perfect right angle, which it's supposed to, and that is how perpendicular slopes work. And with that, that should give you a very, very general understanding of slopes in terms of linear equations. And we're going to use this to help us bust through the rest of the problems that we'll try today. And I believe we got 4 coming up, 2 simple ones and then 2 tough ones. And and when it applies, I'll show you some shortcuts as we go through them. Okay, first one. The average number of students per classroom at Central High School from 2000 to 2010 can be modeled by the equation y equals 0.56x plus 27.2. So this is the equation I'm working off of. And they're telling us x represents the number of years since 2000 and y represents the average number of students per classroom. And now they're asking us to describe what's the best way to describe the meaning of the number 0.56. So first things first, we should acknowledge that when they talk about the 0.56 in the equation mean, they're asking us, what does that slope mean? And in the problem like this, we can work off the answers and see what kind of stupid answers they have and then knock those out and then work off the best one. But if you have a very good grasp of the vocab in a linear equation and how each component functions, it does give you a big leg up. For example, I can see really, really easily that the total number of students at the school in 2000 is 0.56, is a goofy, silly answer. The average number of students per classroom in 2000 is 0.56, is also a goofy answer. The SATs, when they give you real live questions, they'll usually give you numbers that fit the context of the problem. So if we're talking about kids in a classroom, most likely it is not going to be these two things right here. So now we have the estimated increase in the average number of students per classroom each year, or the estimated difference between the average number of students per classroom in 2010 and 2000. Between C and D, I know some of you are already seeing it already that D doesn't really make sense, so then C must be the correct answer. And that's a really good way to work off of it because you can work off the answer. But also, given that today we're working on linear equations, I think it's good to just crank through the problem theoretically, knowing what we know. When they ask what the slope means, we know what the slope means. The slope means the increase in y value, the increase or decrease in y value when x value goes up by 1. So in this case, we already knew that x represents a number of years and y represents a number of average number of students per classroom. So so when I try to translate this sentence into words, or slope is the increase or decrease in average number of students per class when the year goes up by 1. And when you have that, that verbal translation for what the slope means, it becomes exceedingly obvious that C, the estimated increase in the average number of students per classroom each year, is the correct answer. Because we're talking about the average number of students per classroom, and then each year always means 1 year. So this sentence matches this situation exactly, which is a good way to use our conceptual understanding to beat this problem quickly. And now let's try a different problem. Okay, in the xy plane, the graph of which of the following equations is perpendicular to the graph of the equation above? So If you are real comfortable with your three forms of linear equations, you'll notice that all 4 or 5 equations I have right now are standard form equations, and you know that standard form equations are not going to give us any slopes or any information on slopes. So then my job is to turn this into point slope form or slope intercept form so that the slope is exposed to me, to my face. And I will tell you right now, it's almost always easier to transition into slope intercept form because you don't have to do any kind of grouping. So here we have 3y equals 2x plus 6, divide both sides by 3. So then y is equal to 2/3 x plus 2. Now I will tell you, as a math teacher who does well in the SATs, I'm extremely lazy when I know that a problem only talks about slope and nothing else. And if we're only talking about slope and nothing else, that means the y-intercept never mattered to me. And which is why sometimes when I do these problems, I don't really even think about the 6 in my head, because I know the only thing that matters to me is the slope, and doing one less calculation is usually nice. So the slope I have for this equation is 2/3. So when I look for a perpendicular slope, I know the goal is for me to find the slope of -3/2. So now all 4 equations, I'm hopefully going to get the ability to get -3/2. Now, between all 4 situations, some of these we have to check out, although I will tell you for now that some answers are definitely not as good as others. For example, B has 3x plus 4y equals 6. And if I just think in my head a little bit, that I'm going to move the -3x over to the other side. So it's -3x and I divide by 4. That fraction is nowhere near -3 3/2. And I know that just because I can see the components of the numbers and how they don't match up with -3/2. So then from the get-go, this is no good. And I can use that same description to describe 2x and 4y. 2x is actually divisible by 4y. Well, I mean, 2 is actually a factor of 4, and when I move the 2x over to the other side and simplify, the y is going to give me -1/2 x as a slope, so that's definitely no good. And we just do the same thing over and over again. 2x, you move to the other side, divided by 6, it's going to give me -1/3. I don't even care about the signs. I know the numbers are out of whack from what I was expecting. So then that leaves A as my final answer. And if you do check it, 4y equals -3x divided by 2, and then y equals -3/2x, which is exactly what we were looking for. So in this case, I actually showed you the work for the 3 bad answers. But if you can figure that out in your head, this is one of those things where you're doing so few calculations that if you ignore the constant, it's relatively easy to think about how the slopes are related to each other. So you can work through this a lot faster if you choose the right things to ignore. Okay, so that's the last one of our simple problems I prepped for us. Now we're going to try something a tad more difficult. So in this question, in the xy plane, the line determined by the points 2k and k32 passes through the origin. Which of the following could be the value of k? So this one gets weird. And if it gets weird, what I recommend you do is always model it so that you have a visual for what to think about. They already told us that this thing goes through the origin. So then there's a point at 0, 0. Which is vaguely helpful for us. And now at this point, you have 2 points happening. You have 2k, and you have k, wherever that is. and then 32. And right now you might be thinking, I'm not really sure what we're gonna do, what we can do to make sure that to make sure how to find the value of k so that this ends up being a linear line and a straight line um, that passes through the origin. So we're gonna walk through a little bit of the concept, and then I'm gonna show you some cool shortcuts. So the fact that linear lines are always going to be straight and have the same slope throughout the entire line means that whatever slope is happening from here to here has to be equal to the slope from here to here. That's what it means to have a linear line go through a point. This slope has to be the same as this slope. And that being the case, we can actually we can try some shortcuts to crank through this quick. First of all, let's knock out a dumb answer. 0 is out of the question because if I had 2, 0, that would be over here, which is not the main issue. The issue is I would have 0, 32. And 0, 32 would be on the y-axis, and it would be a y-intercept. And we already have a y-intercept at 0, 0, so then plugging 0 in as an answer would not work. And what we're going to do is we're going to keep working off our answer choices here, and I'll show you how to think about this so that everything's easier. A thing to remember about multiple choice is, once again, we're not pulling a number out of like the clear blue sky. I mean, we can, but they already gave us the answer. They just also happen to give us 3 wrong ones. And now that I've knocked out one, now I only have 2 wrong answers and 1 right answer in here. So instead of theoretically setting up some kind of equation to find out what k is supposed to be, all we really need to do is make sure that I try out one of these 3 options until I get to the correct situation. Now, let me show you how much this problem could suck if we don't use the answer choices. The way you would try to do this so that it's not a terrible experience is you would say, okay, the change in x value from 0, 0 to 2k, there's a horizontal change of 2 and a vertical change of k. And then here there is a horizontal change of from 2 to k, there's a horizontal change of k minus 2, and the vertical change is 32 minus k. And if I try to set up a proportion where I try to, between the 2 situations, where I say delta y over delta x, I'm going to get k over 2 is equal to 32 minus k over k minus 2. Now, and then I would have to cross multiply and get k squared minus 2k is equal to 64 minus 2k. And then, okay, let's keep going. Add 2k to both sides. And you'll get k squared is equal to 64, square root both sides, and you'll get k is equal to 8. And that would be our answer, and it would be correct. But you'll notice that I had to do a lot of work setting this up and getting to this proportion, and then cross multiplying and getting this weird mess of an equation that I have to solve by hand to get to k equals 8. First, I have to do that, and that's more time than I want to take. But also, the idea of setting up these ratios so that I can make a proportion is a level of insight that I find most high schoolers tend to struggle with. And that's why, in general, whenever you can, you want to work off answer choices, because that means you're working off of 3 answers as opposed to trying to find it, because now you're picking out one of infinite possible answers. So I'll show you how to do this by working off the answers here. And we're going to get rid of all that marking. We're going to pick 4. We're going to pick 4 as a possible value. Okay, we're going to try that and see if it works. And what I'm going to do is replace k with 4 in all these points and see if the change in x and change in y is consistent between these 2 set of points and these 2 set of points. And from 0, 0 to 2, 4, horizontal change is 2, vertical change is 4. And from 2, 4 to 4, 32, horizontal change is 2, and vertical change is 28. And now, if we now that we have numbers to look at, it's a lot easier to set up the proportion to see if the slope is consistent throughout. So this slope over here is 4 over 2, and this slope over here is 28 over 2, and the 2 slopes are clearly not as consistent. So this answer clearly are giving us bad points that don't work for going through 0, 0. So we're going to have to try a different one. And that is the name of the game. So now we'll try 8. And if I stick 8 in here and 8 in here, I know my vertical change is 8 and 2. And then my changes from 2, 8 to 832 is 24 and 6. And now when I compare the ratios of the change in y over the change in x, I'll notice that it cleans up to 4 over 1 equals 4 over 1. So the slopes are consistent between the 2 intervals that we have. And that's how we know the work is legit. And some of you guys might be saying, like, I still, even though this was easier and quicker, I still took the time to run through these calculations and I still had to set up a proportion. So how is this that different from dealing with a variable? And my answer to that is because I didn't have to do any algebra. Everything I did just now was arithmetic. I turned an algebra problem that involved representing a variable multiple times in different parts of a formula, and I turned it into all arithmetic, which is just adding, subtracting, multiplying, and dividing by trying out my answers. And this might not feel like it saves you a lot of time now, but I guarantee you over the course of 58 questions in the span of multiple hours, it will save you time and it will save you brain energy. So work off your answers, and that's why it's good to have a good understanding of how slopes work in a linear line. All right, last problem of the day, then we are out of here. The cost of using a telephone in a hotel meeting room is 20 cents per minute. Which of the following equations represents the total cost C in dollars for H hours of phone use? So this is a super weird situation right now. We can recognize that this is a linear equation because they're giving us a direct rate of 20 cents per minute. So then, like, the way you kind of think about how to write this equation is like, okay, I have the cost is equal to 0.2 times m, which is the number of minutes. Simple enough. The hard part of the problem is they're making us go in terms of hours. And the fact that it's hours makes it a slightly weirder conversion problem, because now I got to think about how do I represent this function in terms of hours. Like, do you just multiply by 60? Because there's 60 minutes in an hour, right? Well, now we're not so sure because our understanding of the relationship between hours and minutes is, and how we have to convert one to the other is probably not super, super great. And because it's not super, super great, a question like this feels like it can take a while. And we're going to try this the technical way, and then I'm going to show you a different way to do it. And notice that this is a no calculator section. So the 20 cents over here, so the original setup I have is 20 cents per minute, but they want to do this based on hours of phone use. So then when I try to describe the cost, you have to think of the variable I have to use is h, and I have to think about what number is supposed to multiply by this h out here, so that I can represent this equation accurately, even though I'm using h instead of m. And that gets weird. We know that it's 0.2. It's 20 cents per minute. So like this right here is the cost per unit of time. So if I know that it costs 20 cents per minute, the way I would represent the cost per unit of time as a slope over here would be, okay, it's going an hour now, so I would have to take that 0.2 and multiply by 60 minutes, so that it ends up being $12 per hour, which would make sense because that's what 0.2 times 60 is. I would have to go back here and be like, okay, well, A matches the way I did my math, so A must be my final answer. And that's great. That is a way to like work through this problem. But it's not a great time because you have to, once again, really use your conceptual understanding to wrap around what the question's asking in order to do this right. And I'm going to show you a slightly different technique, actually a very different technique. And what we're going to use instead of our ability to convert between units is our ability to make common sense happen. Whatever equation is the correct answer is consistently true no matter how many hours or how many minutes I'm using. If they're giving us this formula, it's always going to be accurate. It's always going to describe the accurate relationship between C and H, so that it's never, ever, ever, ever wrong. So if I pick 1 hour, C will give me the correct cost for 1 hour. If I say 100 hours, C will give me the correct cost for 100 hours. So that being said, I am going to make my own H value in order to get my own C value. And out of these 4 equations, only one of them is going to have a matching situation to the random numbers that I'm about to pick. And I want to make this thing as easy as possible. So I am going to pick H equals 1 hour. And now, instead of using the equation that we could have figured out, I'm going to use my common sense. The cost of using a telephone in a hotel meeting room is 20 cents per minute. And 1 hour is 60 minutes, so I paid this 20 cents 60 times, so then this must be $12. Which you can really just write as 12, ignore these variables because you don't want to think about them anymore. And now, between these 4 equations, I just have to think which one of these equations when I plug in H equals 1, the C is going to pump out a 12. And the truth is, when we look at B, that's, plug in 1, that's 0.2 plus 60, that's 60.2. So that's a garbage answer. Let's do this one. 60 times 1 is 60. Divided by 0.2 is going to equal 300. You can put this in your calculator to check, but that's definitely not legit either. This is 0.2 times 1, and then I'm dividing by 60, and I don't even have to crank that number out to know that that's not legit. And now lastly, if I try this now, plug my 1 in for H, 0.2 times 60, and I get 12, and boom, I got my answer. With I would say slightly less time than the technique where I had to like wrap my head around the problem and do the correct unit conversions. This took a little bit less time, but I think it took a lot less effort because I was able to use my understanding of like the logic of the problem and my ability to plug numbers in to calculate based on what the sentence gave me. Because the sentence they gave us is not hard to analyze or to try examples with if you have easy numbers to work with. It's when they give you variables and theoretical numbers that the problem gets difficult. So now that we know h is equal to 1, c is equal to 12, you just keep cranking them until you get the equation that matches up the situation perfectly. And that is another way you can use your understanding of linear equations to beat these problems. Okay, guys, that's it for today. Hopefully that was helpful.